Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk to you about setting up an environmental load case with a barge spread mooring in ProteusDS. So where last we left off, we had set up a spread mooring with a small square barge and set the mooring to a specific pretension level. And now we've set that up as a starting condition for an environmental load case, and we're going to take a closer look at this. Set up now and set up the environmental conditions. So here's our barge. We've already gone through the process of pre-tensioning the lines. It's ready to go to set up an environmental load case. And what's an environmental load case? We just mean some combination of wind, waves, and currents that we can check the loads in the mooring and make sure the components are the right strength, or maybe we need to make an adjustment to the mooring configuration. So typically we will look at some combination of currents and waves. One way of doing this is looking at an irregular sea state. For coastal areas and even ocean conditions, an irregular sea state John swap might work pretty well. So we'll resolve follower properties for this wave type, and we can specify. I'm just picking numbers here for sort of a mild, moderate kind of sea state, 2 meter significant wave height. Rule of thumb might be 75 wave segments, generally to use to make sure there's no repeating sea surface. And we'll leave the other parameters the same. So we've got a nice irregular sea state set up there. Just keep things real simple, and for a current profile, let's use a uniform current profile. Resolve follower properties on that, and 0.5 meters per second, maybe a 45-degree heading. Now, one thing to set up carefully here is the environmental ramping, the environmental transition and ramping. So what we like to do is ramp up steady loads like those from currents and wait to turn on the wave conditions a certain amount of time. So we turn on the currents, let the mooring deflect a little bit to get the static load resolved in the mooring, and then we turn on and gradually ramp up the waves. And we do that to minimize the chances of any artificial shock loading in the mooring from slamming all the environmental loads on at the same time, right at the start of the simulation. So the current will start right away. We won't, for this case, I'm not going to bother ramping up the current. Wave transition mode is on. Wave start time, we'll say start at about 30 seconds. Wave duration, maybe we'll make it 15 seconds. I mean, you get a bit of a feel for this. And we'll show what the implications are for reporting the results from this. So we're ready to go. We're ready to run this particular environmental load case, and you can run it in here, or maybe if you have a bunch of load cases you want to set up, you can set them up in different folders and then drag and drop those folders into Proteus Queuing Manager and run them in parallel, which is certainly an efficient way to go when you have more than one load case. Instead of running that now, I've actually got some pre-computed results here. So we'll take a closer look at it. The results we got from this dynamic simulation. We can take a peek at the results in PostPDS. Be aware, by default it loads 50 wave segments at most. That's just for graphics and rendering purposes to keep things manageable, but you can adjust it when it's actually loaded. I'm just going to turn it off so it loads all wave segments. And there's our barge. I'm going to switch to engineering view to get a little bit of a better view of the mooring. You can see we can sit and watch it, but we can also slide this along so it's settling with the current load, and then you can see the waves have started up there. You can get a sense of the tension in the system. There's some big dynamic loads happening here and there. Can keep an eyeball on them with the tension plot. A couple of big peak loads here, so it's good to try a bit longer of a simulation and see what's happening. Just try a few different simulations that are set up the same, but with a wave seed to see what the peak loads look like. So that's helpful. A systematic way to post-process the results is with the report tool. So with the ProteusDS Simulation Toolbox and the results open here, we can go to Launch Report Tool. We pick Rigid Body Mooring. Okay, Now remember how we talked about ramping up the conditions? Here's where that's important to keep track of. So it's going to report on statistics, the variation of the loads, standard deviation of the loads, but we don't want to include anything that happened during the ramping periods at the start of the simulation. So we have 30 seconds of time to let it settle with the current, and then another 15 seconds to ramp up the wave, so we'll put in 45 seconds. And then we'll process the rest of the data. And you may want to look at the results in kilonewtons, but it's up to you. So we'll generate the report, and we'll just save this here. Got an old file there. Reads through all the results. Go view report. We've got a nice summary of the inputs, the environmental conditions. You see we had a John swap irregular wave spectrum, 2 meter significant wave height. If you go look down here, we have fair lead results, maximum tensions at the fair leads, mean values, standard deviations, and so on. So it's a nice summary of all the kind of critical values out of the simulation results. And of course, all the raw data is there to look at. Anyway, just wanted to show how to set up an environmental load case, what that kind of looks like, and a relatively quick way to process the results as well. Thanks for watching.